Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Green Booklet, Practice Test 1, specifically Unit 17, questions 57 to 59. And in this unit, we don't actually need much chemistry to answer, knowledge in chemistry to answer these questions. A lot of it is pattern recognition. In this stimulus that's provided, you're actually given a lot of information about hemacetal formation, and then it's nicely written, so you actually don't really need to have any prior knowledge in chemistry to answer this. So if we take a look, a hemacetal is a carbon connected to two oxygen atoms, where one oxygen is a alcohol and the other is an ether, where it's bound to, say, another carbon group. So a key feature of hemacetal molecules is that both the aldehyde and alcohol aliphatic, or the carbon bond structures, they're conserved. So a good example here is if we take a look in the unit stimulus provided, the acetaldehyde and the ethanol example, we see that both the carbon number for the acetaldehyde and the ethanol is conserved, and we're left with an alcohol group and an ether group. So if we take a look at the first question, question 57, we can utilize that same principle. We're told that the following structure, which of the following structure represents the hemacetal that exists in a solution of propanol and ethanol. So without even obviously looking at the options, we can just draw it because we know that the structure is going to be conserved in terms of the aliphatic structure. So we're going to have a propanol, so 1, 2, 3 carbons, and the ethanol, we're going to have 2 carbons. We know that if we take a look back at the stimulus, the hydroxide group is usually on the terminal end of the, let's say, of the aldehyde group. So we're going to have it on the terminal end of the propanol. So it's going to be the hydroxide, and we're going to have the oxygen, so the ether group connecting both the ethanol and the propanol group here. So we know straight away that the answer has to look something like this. I mean, obviously omitting the hydrogens for brevity. So if we take a look through the options in 57, well, I mean, options A and B are incorrect because they don't conserve the ether and the hydroxyl group feature. So they've only just got a hydroxyl group without the ether group. So A and B are incorrect. As you can see that this carbon has to have this, we have to have this sort of pattern. So if we look at C and D, the reason why D is incorrect is because they've drawn it, 1, 2, 3, 4, 5, 6, they've drawn it as a 1, 2, 3, 4, sorry, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. They've drawn it like this. And the oxygen here. So the issue is this is a completely different compound. So what they've drawn is just a, let's say, a 1, 2, 3, 4, a butanol group with a, let's say, a methanol group. But I guess they've drawn it a bit different here. So it looks like the structure, well, whatever the structure is, whether it's butanol, methanol, or completely different, it's not propanol and ethanol. So that's why the answer is C. So if we move now on to question 58, it asks, which of the following pairs of compounds can be used to form the hemacetal as shown here? So again, let's just draw it. Again, pattern recognition. If we just draw the carbons and the hydroxyl alcohol group and the ether, we've got 1, 2, 3, 4, 5, 6 carbons. We've got the hydroxyl group on the 1, 2, 3, 4th carbon. The ether is here. So what we have therefore is a 1, 2, 3, 4. So it's a butanol structure with a ethanol structure. So you can see that we've got the 2 carbons here. So ethanol, 1, 2, 3, 4 is going to be the butanol. So therefore, if we take a look at the options, it has to be option C. Well, option C is the only one that has the 4 carbons in for the butanol structure. The rest are either 3 or 2, which are incorrect. So that's why the answer for 58 is C. Now, if we move over to the last question, 59, it's asking to consider the 3 molecules the hemacetal structure is found in? Well, for structure 1, we don't have the oxygen, so we don't have that ether, with the alcohol group. All we have is just an ether group with an ethanol, with a alcohol group, but they're not on the same carbon. So it has to be on the same carbon. So structure 1 is incorrect, so it doesn't have a hemacetal group. Structure 2, we see there it's conserved, so we've got a carbon there with an OH, O group, OR group, so that's a hemacetal group. Remember, if we employ the pattern recognition. And 3, we're shown a cyclic compound, so remember we have to make sure that we conserve that ether with the hydroxide group. So we've got the carbon here with an hydroxide, and we've got the the ether. So yep, we've conserved the molecule, so we've got that group. So it's a hemacetal. So therefore, the answer for 59 has to be 2 and 3 only. So it has to be D. Now, if you have any more questions about how to, analyze this this unit differently, or how to better improve your pattern recognition, you can post your comments in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.